So living in Silicon Valley can be pretty expensive. So today we're going to take a 1-bedroom apartment and convert it to a 2-bedroom apartment. I've done a project like this before, but this is going to be the best effort yet. I've already made a 3D model of the conversion, and I've already picked out all the parts we're going to need. So it should be pretty straightforward just to recreate the 3D model and turn it into a 2-bedroom apartment. Hopefully today I will show you how to hack rent in Silicon Valley, or anywhere for that matter. Alright, so here's what the room looks like before we convert it, and we got a new drill because we need more power. So we're going to put a wall from right around where that mattress ends all the way across the room to about halfway through the window. And my door will be right around here. And this hallway that's already part of the house will just kind of continue all the way to where my door will be. And then 90 degrees to the right, there'll be a door for my roommate. So the first step, we have to measure the room and get all the important measurements. For example, the window, length of the closet, length of the heater, and various other things like the width of the room, where the outlets are, the height of the ceiling, etc. So I put all those numbers together in this little chart so that I can start rendering a 3D model of what I want the walls to look like. Now that we have the room measured, the next step is to go to the hardware store and start hunting for pieces. There's a few things we'll need. First up, we have the 2x4s. They come in 2x4 by 96 inches, which is also 8 feet. And that's good because our ceilings are about 8 feet high. Next up are the assembly brackets. They're actually called Simpson Strong Ties, and there's a whole bunch to choose from. Pretty much any type of joint you can imagine is available as a bracket. And so the one we're interested in primarily is the one that goes on the end of a 2x4 and just kind of wraps around it. So that way we can make a lot of right angle joints pretty effortlessly with all the holes pre-drilled and everything. We might also need to use right angle brackets and maybe one of these T-joints. So here's the door aisle, and on the right side of it we have a bunch of pre-hung doors, and we're basically trying to keep costs down. So we're just trying to find the cheapest pre-hung door possible, no frills. And it looks like it's this one. It's 2 feet wide by 80 inches tall, and as you can see it has a frame and it has everything except for the doorknob. Alright, and since those doors don't come with knobs, this is the doorknob aisle. And luckily, the cheapest knob is also the one that matches our house. So we'll pick up a couple of these and we'll have lockable doors. And finally, for the styrofoam wall sheets. These are originally meant to be insulation, I believe, but they work well as the walls for our purposes. They're easier to cut than drywall. They're super lightweight, so they're easy to install. And they look good from the outside, so we can just use a bunch of these styrofoam pieces. Although I don't really know anything about using CAD to make proper architectural blueprints, I do know about 3D modeling. So I decided to use Blender in order to create a 3D representation of what the room will look like when it's finished. Inside Blender, you can actually set it to use empirical US standard units instead of the metric system. So I was able to use all the measurements I took earlier to create a 1-to-1 scale model of the room. And as you can see here, I'm just rotating that scale model room around. We included the closet, the window, the heater, a few outlets for reference. So the first thing I wanted to do was get the doors to be in their final place. So I measured the doors from Home Depot and made 3D models of them. They're about 2 feet wide by 80 inches tall, and this is where they're going to go when it's all done. The next thing I did was make the wood frame just around the doors, and in case you're wondering, each different color of wood is just a measurement that's the same size. So I finally built the rest of the wood frame, and I just tried to keep in mind we wanted to limit the number of boards we had to buy and limit the number of cuts we had to make. Once I had the frame assembled, I actually rendered and put in every bracket that we would need to buy. So that way I'd be able to easily assemble a shopping list of the parts and know exactly how many we need of everything. Finally, I decided to put in the styrofoam walls, and what you see here is 7 different sheets. 6 of them are full size, and that's a full size one, that's a full size one, etc. And then one that was a cut that would fit just that gap right there. I then figured out all the other cuts that would need to be made, and the same color pieces are from the same sheet. So I was still able to count how many sheets of styrofoam we would need. And so that was it. With this 3D model, we were able to figure out exactly all the materials we needed and exactly where to make the cuts. And so I prepared a little chart of the supplies we would need, along with the prices that I got from Home Depot earlier, to get a basic cost estimate for the entire project. The next step is to go buy all the materials and start building. Before we began, I used the 3D model to make a chart of the cuts that would need to be made from each board, and then a chart of the individual pieces that we would need for the whole project. Home Depot made some cuts for us, and then we rented a truck to take everything home. Unfortunately, Home Depot refused to cut everything. Some cuts under 12 inches they wouldn't do, so we had to make some of the cuts ourselves. After we had all the pieces prepared, we started measuring and installing the Simpson strong ties. As you can see, the ties made it extremely easy to slide the frame together and keep it secure. In no time, we had the first wall segment complete, the one that extends into the hallway. Now that we had a little experience, things moved much quicker building the second segment, the one that would eventually become the entry point to my room. We raised and aligned the two segments at 90 degrees and used T-shaped ties to hold it together. We accidentally bought the wrong ones, so we had to make a small divot in the wood to make it fit. As we worked, we put soft foam weather stripping on all the ends that would touch the original apartment. This way we could protect the walls from scratches. Finally, we had the frame complete. It looked pretty much exactly like the 3D model. Now it was time to install the styrofoam walls, but first we had to peel off a silver coating that was on one side of them so that they could be nice and white. I had actually built a similar room years before, and there was no silver on the panels. I guess this is something new, but unfortunately it made the walls look less clean than we were hoping. Our ceilings were slightly shorter than 8 feet, so we actually had to remove about 1.5 inches of material from each wall so that they would stand up straight. Only a box cutter was needed to make the adjustments. Finally, we simply screwed the walls onto the studs after measuring and cutting the pieces we needed. It took all day, but finally we had the project complete. Here's a little tour. First we'll start in the hallway that was already part of the house. And as we round the corner, you can see that we now have an extended hallway. First we'll enter my roommate's room, and it has a pretty square footprint. It's a normal dimension for a room. You can see we split the window in half, and we have all the walls up. Next we'll go into my room. My room has an awkward dimension. It's much longer than it is wide, but it does have wall-to-wall bedding, which some people would probably pay extra for. You can see an example of the doors were hung correctly and they close properly. They're a little narrow, but they work. Overall, it was a fun project, and it's an easy way to make a 1-bedroom apartment a 2-bedroom apartment.